This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Become an autonomous digital enterprise and your business can achieve A-game status. Intelligent predictive systems, effortless automation, and technology and people working in harmony. This is the Autonomous Digital Enterprise. Visit bmc.com/agame for more information.
Welcome to Software Engineering Radio. I'm Akshay Manchale, and today I'll be talking to Tug Grall. Tug is a technical marketing manager at Redis Labs. He's a passionate developer and open source advocate with a deep background across the open source community. Prior to Redis Labs, he held positions at the likes of Red Hat, MapR, MongoDB, Couchbase, and Oracle. We covered Redis previously in episode 209. This episode will go over the basics, and then we'll talk about more emerging use cases and how it's currently being used and managed. Tug, welcome to the show.
Hello, welcome. Very happy to be here. So thanks for the introduction.
Great. So let's start off on a very high level. Can you talk about what Redis is and what it's used for?
So Redis is one of the many databases that you have on the market. And it's part of this NoSQL movement that was created in 2007, I will say, where you need new database to handle new use cases around speed, scalability, flexibility. And Redis was created as an open source project by Salvatore when he needed a very, very fast dictionary for data he wanted to access. And he created in open source a key value store purely in memory. It's the initial DNA of this database. And over time, in more than 10 years now, the community added more and more features to the database.
So what sort of applications is Redis used in?
So technically, it's used in almost any type of application, but it's solving one of the problems very quickly, and it's very fast access to the data. So this is why you will see as an entry point for the projects that use Redis. Redis is used as a cache. It's used as a session store, as initial project. And this is one of the reasons it was built, because when you build an application, you want to access the data as fast as possible. And especially if you know that you will access the data multiple times in a row, like a session, so user sessions, it doesn't make sense to have to go back to disk or do a long network call to do another database and so on. So people start to use Redis as a simple key value store in memory for this type of use case. And over time, because it's very simple to use, they start to do more and more things with the data. And keeping the same logic of being very, very simple to use, the community on Redis has 10 different core data structures, from single strings, from list, from set, from hashes, so type of data structures that will help you to solve specific problems for your application that go a lot beyond a simple session store and cache. You can use that to store your e-commerce kind of cart with information about what you want to buy, to do some recommendations in very, very fast access. So if you look at it from a use case point of view, because it's used to share data between different calls or different services, it could be used in retail or e-commerce to build a cache at the top of a catalog, to build a session of a user, cache over a catalog, session of users. It's almost any business you do today. If you talk about shared configurations, because you want to have different services in different technology that want to share, for example, a specific configuration, you can use Redis. You can have a service in PHP that will save some data, a service in another language that will want to access this data. And this could be just to exchange some event or exchange some configurations. So this is why, in terms of use case on industry, I like to say Redis is everywhere. Usually when you meet a developer when you work on Redis and you go to a developer conference or you do a meetup or something, you go in the room and you say, who is using Redis or who has been touching Redis? You are sure that almost everybody has seen, heard about it, or they know that somewhere it's there, because it's also Redis embedded in many, many solutions, like CMS, like e-commerce platform. It's used internally by default to cache the data. So this is a kind of the DNA, speed and simplicity and scalability for your data.
So a lot of the speed and access, it's accelerated by keeping things resident in memory as opposed to disk in databases. Is that right?
Yes, this is a choice that the Redis team and the philosophy of Redis has been, we want that to be in memory. Like that you have consistent kind of latency. So usually we look at, when we monitor an application, we will look around 1 or less milliseconds to get the operation done. But the good part of being in memory, it will always be that. You just need to be careful about how you scale, in the sense that we don't necessarily store the data in memory only. That means you can choose when you configure your Redis to say, I want the data also stored on disk, just in case you have to stop the Redis, or if you crash one node, when you restart, you will load the data from disk to memory. But when you work in your application, it always goes into the memory, and all the data set is in memory. So, and the main reason is to be sure that me as a developer, I have tested my applications, I know that this specific operations is taking half of milliseconds or 1 millisecond to get the data, and to do the comparison between these two lists. If I do that today, if I do that tomorrow, and if I do that in 1 week, you will keep with the same kind of performance, because the data will always be in memory. On traditional database, you may have the data that you have not used. So let's say you want to compare two lists, and it's right now in memory, great. But over time, because it will not be used, it will go back to disk. And when your application will need it, you will have to go from disk to memory and then get back to the user. So this is one of the things that make Redis very, very interesting for application, when you need to what we call the real time, in the sense that you know that the time you will spend to get access to retrieve the data out of the database.
So what sort of data do you normally store in Redis? I know there are certain data structures that it supports out of the box. Can you walk us through some of the simple ones that are commonly used?
So you have 10 data type inside Redis core. What we call Redis core is really the Redis you are thinking about when you're asking me the question. So the reason why I say Redis core is because, and we will talk about that over time, is Redis as an extension mechanism that is called modules that allow you to create new data structure and new command. So in Redis core, you have the key. And when you have the key, then you will associate a value to it. This is why we talk about a key value store. But people will often say, key value store, it's a simple key and it's simple value. In Redis, it's not the case. It's a key, simple key, very easy to define. You define the way you want. The smaller, the better. Why? Because it's kept in memory. But it has to be long enough or clear enough to, as a user, that you understand what this key is. It is a UUID that has no clue what it means. It's not necessarily easy to read. So associated to this key, you will have a string that could be up to 500 megabyte. Be careful, okay? Because you don't want to always, because it's not only the place that you put that in memory, it's a network that you have to pay. So you have a string. The string is very often used to, if you have to cache an information about a subset of HTML content, an information about user informations, a result of a web services call, and you don't really care about how it's structured, you will use a string. You also have hashes. So behind your key, you will have a set of other field name and value. So typically, instead of having a long string that contains using an XML or JSON for some information about a profile user, like your first name, last name, and so on, with a hash, you will be able to, behind the key, have the name, the field name, first name, last name, and so on. The benefits of that is the fact that you can have as many fields as you want. So you could be thousands of fields. And when you save, when you retrieve, and you do an increment, you can have a subset of this field. So the hash is a way of organize, a way of structured content or data structure. So typically, if you do a product catalog, you may use this as a data structure where you will have the SKU as a key and then a set of fields. And when you retrieve and communicate with the database, you will only save or retrieve a subset of this field depending on your business API that you want to deal with. So in addition to this core kind of very used data structure, you also have sorted set on set. So this is you can put value in a set and you can query them or add on manipulate or navigate into this. On sorted set, it's the same. You have value associated to a key with a score. And a common use case for the sorted set is ranking in gaming. So if you want to have the top 5 player for a specific things, or what are the most downloaded features and so on. So you want to organize content in a way you can sort and query very efficiently on a specific sort, order by. You will just associate the keys that will be top 10 user for this game, and you will have the name of the user, a score, and so on. And when you query that, you will just have the capabilities of reading this. And you also have lists. So lists are very basic structure. Not necessarily basic in the way they are implemented, but the way you manipulate. And with everything you can do is pop and add feature at the top, at the beginning, or the end of the list. So this is many of the core features that you use for applications. And then you have other like pub/sub feature that allows the user to do publish or subscribe data on event. It's used for notifications. It's used for communicating between two different services in real time. Like that, you have one system calling another one. And in Redis 5, one of the data structures that I really like, because I work a lot with messaging technology before, it's Redis streams. It's a log of event like a Kafka, more or less like a Kafka. So you can send an event, store the event to the database, and then you have a set of consumers that can read a part of it, read entirely, retry, so allowing you to do some good on advanced messaging application using Redis out of the box.
So is that like a durable messaging system like Kafka, or is there a difference there?
No, it is durable. It's with the trade-off of being in memory, right? So when I say being in memory, once again, it does not only sit in memory. It could be saved on disk. You choose when do you want to save. When you configure and when you start your Redis instance, you can say, I want only memory, so I don't want to store anything on disk. Or I want to save on disk every 6 hours, every 4 hours. So this could be good if you, for example, have a big cache and you want to, you are exporting every day a big data set from the mainframe into Redis to have a very fast access, and you don't want to have all the processing even if something crashes in one of your containers and so on. But you can also do append only. So append only will be every transaction or every mutation or every seconds you can save data on disk. So if we talk about this specific use case of having a persisted log, when you do an add, xadd is the command, xadd is the command, xadd one message, xadd another message, you can choose to save on disk every time. So it will not have a big impact on performance because it's done asynchronously. So we say it's single thread. We often talk about the single threaded application in Redis. It's true on the server side from operations, but everything that is related to replications, that is related to saving on disk, is in a different thread to avoid impacting the performance. So in this case, you will save the data on disk. So it's persisted, and it allows you to play again with the data whenever you want. I just want to add something a little bit specific on this is, as you know, as you mentioned, I'm working for Redis Labs, and Redis Labs is adding also some other features to the community versions in the enterprise version. On one of the use cases he has, it's you can use something called Redis on Flash that is only available in enterprise, but the idea is to, if you have a bigger data set with cold or cooler data on hot data, you can have some of the data that will not sit in memory all the time. Keys will stay in memory, some of the value will be on disk. And in this case, we are closer to a very, very, very fast database that is disk plus in memory.
So, in some sense, Redis is used as a cache on top of other data stores. So you can have updates going into your primary data store through Redis. Maybe it's going out of Redis. How do you manage recency of data?
So you have many different ways of doing that. And also, I will, just to be a little bit controversial, is you also have a lot of people that are using now Redis as their primary database for their application. You can use, and you should, use Redis as your database. If the data model fits, if you don't need it present somewhere else, it's possible. So to go back to your questions about, yes, when it's used as a cache, the biggest challenge with all the caching technologies on caching infrastructure and architecture is when do you invalidate? How do you know that you have to go back to the initial data? So here you have different options. Depending on this you have no magic here. It's really first the developer has to understand the data is manipulating. So for example, if I take a very basic example that is very simple to implement, and in this case it's quite easy. Suppose you are calling a web service that is giving you the weather forecast in your kind of area. You are building a farm agriculture kind of applications, and you want to give forecast. Forecast will not change every 5 minutes, right? It's okay if you cache for 1 hour or 2 hours the forecast for the next 5 days. So in this case, in Redis, the simplest way will be to simply say, put a TTL, a time to live, and expirations of 1 hour. Like that, as a developer, you have nothing to do. You set the value, so you call the web service for the weather, you set the value in Redis, and you say in 1 hour, delete it. It will be done for you. When you have something that is more complex, it will really depend. Do you have access? Can you have some notifications about the initial data source? And what we see more and more is, we were talking about Redis streams on Kafka 2 minutes ago. So if you are using an event sourcing kind of approach or messaging approach, you will use that to invalidate your cache. You can receive the event and say, when I receive this type of event, I will invalidate the cache. And you have two ways of doing that. Either you really invalidate the cache, you just delete the object, or you can also ask the system to go into the main data source and put that in the cache. This is also how we see a lot of CDC, change data capture integration. So in this case, you plug your initial database that captures the transactions, and you push the event inside Redis. So to keep the data up to date based on the initial data source. So in this case, it's coming from the golden record, that is your mainframe or your Oracle database or MySQL, pushing data back to Redis. Lately, we using a module called Redis Gears. So it's a part of the ecosystem that is available in open source. You have an interesting use for that. It's doing a cache write through Redis. In this case, your application can interact only with Redis. But when you modify something in Redis, you will push an update in your relational database. In this case, if you modify something in Redis, it's always up to date, and you will eventually, using Redis streams and so on, push the update into your relational database. So you see, you have different ways of doing that. The key in this part is, when you work as a developer, as an architect, it's try to first understand that caching, you always have these questions about how long my data will be valid, what's the event that makes this data invalid. Is it something that I can control? Is it something that is only time-based? And if it's something that I can control, what will be the best solution for that?
So you mentioned there's time to live for certain data structures, right? So let's say something actually expires, and then an application is trying to look for that particular key. Does it actually reach out to the database first and then do a put on Redis, or is it just reaching out to Redis, and then Redis, if there's a cache miss, populates it from the data store? How does that work?
I like the way you ask the questions, because it makes me thinking, it goes back to the initial DNA of Redis, as simple as possible. Make it simple. What does that mean? That means it doesn't do anything for you beside expiration. So what happened is, if we go back to this example where I have to call the database or a web service, after 1 hour, if you try to get it, and he will not return the value. He will say it's nil or the key does not exist. What happened in this case, it's depending of exactly when is it in the process, the key will be really out of the database because you have some cleanup jobs and that will really delete. Or what's happening, it's if you arrive just 1 second after or 1 millisecond after the expiration, he will check if the time to leave has been done, and if it's done, he will delete and return null. So by default, you will not try to go back to call the web service or call the database for that. This is usually something that you put inside your application. And you have many systems that do that out of the box, but it's not inside Redis. When you work, for example, with Spring in Java, you have many frameworks. You can activate some kind of level 2 cache in this case. In this case, what will happen is Hibernate, Spring Data, and so on will work automatically by themselves to see if they need to put the data in Redis or not. And they will deal with accessing the database. What you can do, you can build some stuff yourself to say when inside the database using some Lua script, using some specific services or even a module you can build to call the database yourself. But the thing we have to be aware and careful is we want Redis to be as fast, as simple, as efficient as possible. So where is the best way to call the data? So to get the data out of the golden record or the main system of record, it's really based on your application on how fast it has to go. The traditional way is I try in the cache. If it's not in the cache, I call the database, I store in Redis, and I return the value like that after it's back into Redis.
That's interesting. One of the other things that I know about Redis is also known for probabilistic data structures, and it's a topic we covered previously in episode 358. Can you tell us what probabilistic data structures are present in Redis and how they are commonly used?
So you have in the core, you have hyperlog logs that allow you to increment value in an efficient way. So the idea is to count value, billion of values, keeping the number very, very, very small. The memory size very, very small. If you want to count the number of hits on a specific movie or something, for example, you are YouTube and you want to have a quick calculation. So one of the things will be to see how many times a specific resource is available and has been accessed. So the hyperlog log will do that. And it will optimize the size, and it will stay to 12K in memory, very efficient, even if you have big numbers. The price to pay in this case, it's an approximation of the data. So if you want to know exactly to the exact unit, it won't be this case. And this one is in core in Redis core. When you use one of the modules developed by the community, it's called Bloom filter or Redis Bloom. And this one is based on Bloom filter. So it's to check in a very, very, very efficient way if something is in a list or not. And the interesting part is, I just have to be right in the the way I express that, is it's if you want to quickly know if a value that you are checking is part of a list or not, and instead of having to control a very large set of data, you will do a guess that will be more or less the fault or the tolerance will be bigger and smaller depending on how you configure and how you want to big your space in memory. So the idea is if it says yes, it is in the now I have a dot. But the idea is you will do a check. Is this value part of my filter? Yes. If it's part of my filter, you are sure that is in the filter. If it's no, now I have a dot. But the idea is
it may be there.
Yeah. In one case, it's maybe it is, or maybe and I should. And one use case for that, I was discussing with a developer. Right now it's AWS reInvent, so you have a lot of conferences and right now happening. And I was discussing with one of the users of Redis in India, and they are doing payment platform. So they have many merchants, And when they want to do A/B testing between different features, they have millions of customers, and they want to check if this customer is part of this city, and if he has bought a specific item in the last 6 months or the last 24 hours, I want to show this feature, and I do not want to show this feature because I'm testing new kind of feature. This decision has to be very, very fast. The rules is very simple. Is it part of this list, or this list? But doing these 2 or 3 tests has to be very, very, very efficient because you have to do that for millions of users with thousands of features or hundreds of features. So this is typically where initially in Redis, they were using sets and they were comparing sets. But the issue, it was taking a little bit too much time, even in Redis. So they switched to Broom filter, allowing to have, instead of few thousand of merchants, to have more than 1 million of merchants into the database and be very efficient. So the idea of being probabilistic, it's yes, you are not 100% sure, but you do it very, very, very fast. So you're allowing you to add new features to your system. You just have to understand, not like I just did, exactly what the trade-off is, because it's all about trade-off.
Yeah. Well, with this, since it's not an exact answer, but it's also being served from the cache, you have a risk that it might just go away. Like, your instance restarts or something. Now, whatever you have in your Bloom filter is actually lost. So how do you reconstruct that? How do these probabilistic data structures come back up online and give you an efficient answer reasonably fast?
So the way, my answer for that, you will probably feel funny in the way, make sure that it doesn't disappear. So how do you do that? You can use persistence on disk. It's one case. The other one, and this is if your data in Redis is important and it's complex to build because it's either a large volume or because it's a Bloom filter, so it's long. It's based on, the volume is small, but it's based on 1 million of entries. You should use persistence, but more importantly, you should use high availability. You should put in a Redis in a way that you have master and replica, so you have a copy of your data inside the cluster, inside your environment. So it's very easy to do with Redis. So you just create a cluster or an environment where you have multiple Redis running in multiple machines. So every time you will modify your value, it will be replicated to another node. So like that, if something happens, it will fail over to this node. So I don't answer your questions because I don't have an answer. If it's million, you have to save the data somewhere, but you don't do it manually. You use persistence and you use replications, giving high availability to your Redis instances.
Okay, yeah, that makes sense. I want to talk a little bit about the query aspect of it. So, you can do lookup by keys, you can look for existence checks on lists, but what is the concurrency model of all of this? Is it always consistent with respect to another write operation coming in? How does that work in Redis? Is it transactional?
So every operation is atomic. Nothing will happen in only one operation after the other. So the part is you can guess and you understand what's happening. So you don't have transaction in the sense you cannot do begin transactions, modify, and rollback. But what you can do using pipeline and transaction is you can be sure that operation 1, 2, 3, 4 are happening one after the other, and nobody else will come. Because being single-threaded, that doesn't mean that you cannot have multiple clients running on the same server. Obviously, you have many clients. But with the APIs that you have inside Redis, you can be sure and you can force when you need to do exactly what you mean. For example, you want to increment a value, set something in another key, retrieve some values, and you want to be sure that nothing happened between these first operations and this third operation. Only these 3 operations have to go together. So this is what we call a transaction in Redis. You can do that. This is called transaction and pipelining. Obviously, you should not do that all the time because it will impact the other clients that will wait a little bit until this 3 operation has been done to continue. So in this case, it's managed by Redis server itself.
Okay, interesting.
Become an autonomous digital enterprise and your business can achieve A-game status. intelligent predictive systems, effortless automation, and technology and people working in harmony. This is the Autonomous Digital Enterprise. Visit bmc.com/agame for more information.
I want to switch gears a little bit and talk about some more emerging use cases that are coming up with Redis. I see that it's being used in machine learning stacks. I see it's being used in search, graph databases. So there's this whole array of new use cases that Redis is being used in. Can you talk about some of the more interesting ones that you think are non-traditional uses of Redis that is being used today, and some examples?
So one, it's a very good sequel to what you just asked in terms of, transaction or querying. Is one of the things, Redis is very fast. Redis is quite easy to use. The API is quite simple for the developers. One of the challenges is, suppose we have, and I will go to the exact answer the exact question you ask, is I use hashes to store all my connected users and last week connected users. So I have hundreds of thousands of entries, but I would like to do a simple query. So can you give me the number or the top 5 or the number of current connected user coming from California? If I want to do that with Redis core without anything, I will have to manage myself because I cannot do a full scan. So what I will have to do is I will have to use a hash to store the user profile that contains the state, but I have to somewhere have a list of the state of the connected users to be able to get this value. So I will manage my index on the relation between my hash and my list of connected users for a specific state. So it's a use case that people use, but only very advanced developers will be able to do that. The people that have the time to design this and really, really, really need this kind of milliseconds latency. In reality, this request was becoming more and more regular in the discussion of I want to do that. So this is exactly why Redis community and Redis Labs started to develop modules that answer this type of question. So one of the first modules was how we can do indexing, querying, and full text search inside Redis. To take exactly the example that I showed is you want to store the hashes and you want to be able, without having to manage yourself, just creating an index saying, okay, I have a hash that has a key, the pattern of the key, it's user, column something. Everything that starts with user, I want to index them with first name, last name, and state. Like that, I will be able to do some queries. So one of the use cases that is coming more and more often is to be able to query by value in a very simple way, and it's done using a Redis search module. So in this case, it's just by providing more advanced capabilities in querying and aggregation. So you don't need to go to a third-party tool to do that. Using the same approach, developers want to create complex applications using graph database. They want to be able to quickly do anomalies or comparison to find some pattern and be able to analyze an impact of something. And the goal of the community of Redis and the modules was to give a module that will help them to do that. So this is why Redis graph was built. So you see querying and indexing, doing graph queries, and for the same reason you have time series. So be able to organize in a very simple way using the simplicity of Redis, where you can organize time series, do queries by tag, find a very fast interval, and so on into the data. And for this, the way we approach that as a community and as a company is to what are the main use cases in terms of I want to work with this set of data and provide a data structure and the commands. So typically you will see we talk about Bloom filter, search for indexing and querying data by value, including full text search, time series, graph database, and you also have gears. I talk about it's kind of some eventing system or serverless programming because you can add some programmation on application inside your database. And you talk about AI. So artificial intelligence, machine learning globally is becoming more and more important in many enterprises. And what's happening? More data, more need. you need a fast access to the data. This is where Redis comes to the picture. And what happens is people can store the data as a cache, like we talked at the beginning of the discussion. But what is more interesting, can I cache a part of my model? Can I use the tensors and from TensorFlow or something inside Redis? So the community and Redis Labs has built Redis AI to allow you to add inside Redis a part of your artificial intelligence kind of infrastructure and architecture to make your application faster and easy to manage.
So is it fair to say that it kind of like caches the model for you to give you the response based on whatever approximation that the machine learning model does, rather than being used for learning itself?
Yes, exactly. It's more to the result to do the result of the model and the inference of. I've not personally spent a lot of time on this module. We are adding more and more example as we speak. It's something that is quite important these days. You have a lot of investment in the development to show more example. But the idea it's more on the execution of the model in the application to be as fast as possible.
So you also mentioned several times about Redis gears, and it's used in serverless programming and as a computing thing on data. Can you walk us through the examples in a little more detail about what Redis gears is?
So one of the questions or use case is you use Redis and you want to react on some specific event and you want to process some data on a specific event. So for example, you want, obviously, first of all, when I talk about serverless or computing inside the database, it's related to the data, right? It's not to execute a web server. It's really to process and manipulate the data that you have inside Redis. Do something with the data that you have from Redis. For example, you want to be able, when you have a specific event or on a specific cron job that you want to run, instead of having to run something outside Redis, you can do that inside Redis. And so one example will be when you have a specific data or an update on a specific data, you want to modify some other data in your overall database. So you kind of want to do a trigger that will add some information and modify, and you want to do that as close as possible from inside the DB, instead of calling something outside and having the processing and all this being outside the database to modify again the DB. The idea of gears is to be able based either on event inside the DB when you insert, when you have so you will have a specific thing happening in the DB, including a cron, so a specific scheduling. Then you will execute some code, and depending on how you develop and deploy it, it could be created today in Python, and we are working to implement this logic in Java and C and so on. And the idea will be, and this is important when it's at scale, because if you have a small data set with a single process, you can put the process on the same server and it will be almost the same. But imagine you have a distributed database. So you have not only replication for high availability, but you have multiple processes where you what we call the clustering inside Redis, where you distribute the data, you shard the data based on some keys rules between different machines. So what is nice is the gear itself, the business logic that is running, is on each of the machines close to the instance, inside the instance. So you will distribute the processing in parallel. So you can imagine like a MapReduce approach of the data, because you will distribute the load, you will do some aggregations on efficient access to the data. This is what Redis Gears is for. And the idea of Redis Gears is two things. It's to have this for you as a developer to use it and extend it if you want. I use it sometimes as part of the demonstration that I do, is just to capture an event, put that on a messaging system, and then you consume the event. Or you have a write behind cache. This is a write behind feature where we use Gears to capture the event of a modification inside Redis, and some simple business logic to connect to a relational database and do the update or delete or create into the relational database. So in this case, it's just consuming the event, manipulating the data, interacting with an external system.
So one thing I want to clarify, initially you said that Redis is single process, single threaded. Gears are in line with that single process operations, or is it outside of, is it asynchronously sort of executed?
So the thing when we talk about Redis as a single threaded process, it's not really on a single threaded process. You have other processes like saving on disk, replications, gears, executing gears. The single process is where you interact with the data. So when you have multiple, so suppose you have a single instance of Redis and you have hundreds of client applications writing in it, and you have many doing sets, some of doing deletes, some doing gets, and so on. These commands are always on the same thread. So like that, you don't have to do concurrency management, locking, and all this stuff. It's always in the same thread. This is where it's single-threaded. You have other thread outside, and typically Gears is doing some threading outside. So it doesn't break the model of being single-threaded, because a single-threaded is when you manipulate the data. So when Gears is writing the data, it's back to the single thread, but the execution engine is on a different thread.
Okay, so your latency is still the same with respect to your operations coming in, or throughput rather.
Yeah, this is really exactly. This is really the focus of the design of Redis. It's to be sure that writing data, reading data should be consistent in terms of expectation.
Right.
And the design is around that. So this is why when you size your Redis cluster, you have kind of some basic rules. You will say, I will put I will use a few cores for one core for each instance and one or more core for the other stuff. So you can have multiple instances of Redis on the same machine. So you will take 3 cores for each instance, 1 additional core for Gears, I/O, and so on. And you will say, I will use 25 gigabytes of data in each of the process, and I will, on an average, obviously it will change depending on the use case of the data set, but I will say 25,000 operations per second. I can start with that. If I don't know exactly what my use case, I am safe, and then you can tune in or big or not. So it's really optimized to work on the multi-core stuff. So it's because it's single-threaded. You don't have, this part of the process is single-threaded. It's very simple to tune and leverage the power of your machines. Just keeping some memory on core for the other part, like IOs and network applications and these kind of things.
So let's say you start off using Redis to accelerate your application, and then you notice that you need to scale up. What are the signs that tell you that you need to sort of increase your memory footprint, or maybe even distribute and add additional nodes? How do you go about that?
So one of the thing is usually you have two things to look at is what's the latency of your application. You just to be sure you don't overload the system. And the other part, so this is a number of operations per second in this case. You just look at how many operations per second I have on my machine. And if it starts to have a latency, and you look at where it's waiting, is it waiting to access the memory and so on, it's waiting to access a specific part, you will split the database in multiple processes. So you will shard the data to be sure that it doesn't wait too much. You distribute the load in terms of operations on read and write. So this one is just looking at the latency. The other part, it's more a safety net. I was talking about replication for high availability. So you can suppose you have 1 terabyte of memory inside your machine. You can put I've not tested it, so I don't know, but you can put 500 gigabytes of data in one single Redis. It will work, not an issue. If you don't have millions of operations per second, it will work perfectly. But what happens if your data, we go back to the discussion about what happens if this crash? You have to do an upgrade of your server. You have to, you have a crash of the network and so on. You have replicated the data, right? It's good. So you have a copy. It's perfect. So you will go back to the other node. It's working perfectly. But the issue with that is you still need, if this one of the server has totally crashed, you will need to restart the server, and you will need to recopy the 500 gigabyte from this specific instance to the other instance. So it will be costly in terms of operations on your network. So this is why one of the best practice is to say on a single instance of Redis, try to stay less than 25 gigabytes. It's not a hard limit. It's just a good practice, because like that, if you have to replicate the data, restart from disk, move the data, do an upgrade and move the database to another server, it's a lot faster to move 25 gigabytes stuff than a big thing that you have to load back in memory. So to go back to your initial questions, you look at the number of operations per second. If you start to see latency and too much wait time between requests, you have to distribute the data to distribute the load. If your instance are becoming too big, you should distribute the data for safety. When I say safety, it's something wrong happen, how fast it will go back to normal.
So time to recover your data is really a really important factor there. Yeah. So let's say you do have a multi-instance Redis. So now you have your keys that are distributed across different instances, possibly different clusters or different physical machines itself. How do you find what you're looking for? Is that something that's left to the application?
So no, it's not. So some people will do it manually, but obviously Redis has been built to help you to scale out and distribute the data. This is what we call the cluster on the cluster API. So what will happen is you will distribute the keys in small virtual slots of 16,000 on something virtual slots. So you take the key, it has a hash, and it will give you a number between 0 and 16,000 something. And this slot will be on one of the physical server, one of the instances. So if you use clustering, it will automatically find where do I have to go to find the data. So this one is done automatically by you if you are using the proper client. Or if you are using Redis Enterprise or Redis Cloud, it's transparent because you are connected to one single, what we call the proxy, that will do the work of distribution. What you have to be careful, we a little bit earlier in the discussion, you asked about transactions, and I told you that it's possible to begin something, do step 1, step 2, step 3. This step 1, step 2, step 3, step 5 has to be done on the same instance, on the same shard. You don't want to go back into the very complex use case where you start something on this node, you have to finish on the other node, so kind of a two-phase commit, global transaction story that you don't want that. This is very complex, you will have a big impact. So the question will be, yes, but you are telling me that Redis is distributing the data all over the place. How I manage that? So you can, and this is something what we, when we talk to the developers and we are kind of doing educations or discussion about scalability, we say from day one, if you know that you have a big data set or a big number of operations per second, think about the clustering. You don't necessarily have to implement it immediately, but understand the impact because of what I just said. Suppose you are building a system when you have customer and some information about the customer, like invoice or product, and they want to be linked together in two or three different keys. So what you can do with Redis is when you create the key, you put a hash in fact, by default, if you put something between two brackets in the key, this will be used to calculate the slot. So if we talk about the customer, and inside your key, you always have customer ID. It could be the customer profile, it could be the list of orders, it could be the list of calls to the CRM, it could be anything you want. And in this case, what you do is you put this hash, and Redis cluster will be sure that everything that has the same hash, so the customer number 001, everything related to customer 001 will go on the same shard, so on the same Redis instance. So you will still distribute the data, but at least you can control a little bit where the stuff is going. The idea of clustering, if it's well done, it should be transparent for the developer, efficient, but still giving you the flexibility of this kind of use case.
In other words, the application developer has to do some sort of data modeling to be able to place data depending on the operations and business logic. Yeah.
If you need to have this kind of what we call multi-keys operation.
Okay. Yeah. That makes sense. So what are the trade-offs with respect to replication? If you have multiple instances, do you usually do synchronous, asynchronous? Is that configurable? How do you go about that?
It's done asynchronously for efficiency. So keeping in mind that what we want is we want to be sure that default operations are fast. So the challenge in this case is, since it's done asynchronously, you don't know if the replication happened by default. So your guess will be, I will save my data on disk, I will replicate, so like that. In 99.9999 situations, my data are safe. So even if I break something, it will either take the replica or take it from disk. I am safer. So for most of the time, you just don't care about replication. You just activate it. You say, I want the replication enabled, and you will replicate the data. On some operations, and this is at the operation level, this is what is interesting when we talk about Redis. And many other NoSQL databases will have the same some time of approach. Instead of giving the rules, the basic rules is by default, I want to be it simple, I want to be it fast, I want to be it replicated on high availability. But some operations in Redis, you may want to say, these specific keys, when I do these specific operations, I want to be sure that it has been replicated. So I will wait until it's done. So we have a specific command inside Redis that is called wait. In this case, you will wait for the replication to happen, get an exception if it failed. That doesn't mean the write has failed. It could be just the replication has failed, and you can choose, I don't care, I will eventually do it. Or you can retry. So by default, asynchronous, transparent, I don't care as a developer, but if for specific operation, I can control it and wait for the replication to happen. But in this case, as you can guess, the price to pay is you have to wait. So the latency for the overall operation will be based on your replication factor.
Right. And is that the same approach for durability? When you say you can back up your Redis data to disk, is it the same sort of guarantee that you can, or configuration that you can have?
So it's I will say no, the way it really depends of the version of Redis Enterprise, open source or not. And because in Redis Enterprise, the replication is done in memory. So you control only the in-memory part and you don't care about the disk. In open source, but I think this is where I will have to check in detail in which version, but I think in newer Redis 6 version, even in open source, before it was done by disk. So if the replication is done, it was always on disk. So just to be sure, I clarify this. You cannot control to wait for a write or replication. You control the replication. But in some open source versions, the replication is made from disk, not from memory.
Okay. So what are the operational complexities of going to a clustered system versus a single instance? And are there modules or what's in the ecosystem to sort of manage operational complexities? What are the operational complexities and how can you manage it?
So it really depends. Your operational complexity in high availability, so replication, and cluster distribution of the data really depend on the type of environment you have. One of the things that I want to start by is more and more users of Redis use managed services. So in this case, operational is just put your SAT on the cloud, you have it, you choose your plan, and it's done for you. If you are running that in-house, this is where it's becoming important to understand how much time you want to do on ops versus doing on buying an enterprise software. Because each instance of Redis is very simple to do. To be honest, if you want to start a cluster on your laptop on 2 or 3 machines, it's not that complex. You have to put some files, just be a little bit careful about in which order you do that, check the configurations. Then one day you may have to do an upgrade, so you have to be careful about this. So it's just a lot of control about the configurations. If you run with the solutions like running on Kubernetes or running on Redis software, Redis Enterprise software, all this part of clustering, high availability, upgrade is managed for you. It's one click of a button or a CLI. So It's not complex, even in open source. The important part of the open source, it will give you as much high availability as you want, but you will have to do the configuration yourself. And it's mostly be careful configurations on how you start the processes on your different machines. So the very important part, if you want to do something serious and you want to manage that yourself, so you don't want to use a managed service on the cloud or you don't want to use an enterprise software, you have to have a DevOps team or an ops team that can automate things. Because you will add more and more. If you know exactly the size and you only need 3 nodes and 3 processes, it's not a big deal. In this case, even me, that I'm not a DevOps expert, I will be able to do it. But if the goal is to scale out and you may add more and more data, more and more use case, more and more database, you really have to be sure that if you don't use a managed service, you have a good automation of your configuration.
Yeah, that makes sense. So I want to drill down into some of the pub/sub system or pub/sub support that Redis has. Can you talk about who the publishers and subscribers here are? Can you have like users who are subscribing to changes from a Redis instance? Is that how it works, or is it Redis to Redis?
So you have two things when we talk about on your specific question pub/sub. The Redis users, when they think about pub/sub, is really thinking about two commands: publish, subscribe. And this is command in the core Redis. In this case, is the key, when you do a key in Redis, you have a key and a value. In a publish, subscribe model, the key is called a channel because it's not persisted. So you do a publish of a publish user notification and you send a message. And it's published inside Redis. Okay? Nothing happened. Until you have some subscribers that can subscribe to one or other messages, one other channel, one or multiple channel. In this case, it could be a Java application publishing a message on many different systems. It could be one Python, one Go, 25 Java, and so on. They will, if they are up and running when the message is sent, it will be pushed and consumed by all the subscriber. So it's from a Redis client application to another Redis client application. So this is, and when you use publish subscribe, this could be done either by your application publishing an event, or you can what we call the key space notification inside Redis. You can configure Redis to say, when this key pattern, I want to be notified on this channel when this pattern is a new key, or it's deleted, or it's expired. So for example, when we were talking about the caching expiration earlier, I can, for example, I didn't think about it when you asked the questions, but I can say, if we talk about this web service calling the weather API, I can, using publish subscribe, so publish will be done by the database automatically. Every time one of the key concerning weather API expired, it will send an event. My application will subscribe to it, call back the service. So one way of doing publish subscribe messaging is using the publish subscribe, but it's a fire and forget. But I fire, I don't know what's happening, I don't know if somebody is consuming it, and I should not care. So it's good for really real-time notifications and this kind of thing. If you really want to know about having messaging where you want to send a message, persist it, control, the consumer can control only once, at least once, have a pattern about retry if it fails and so on. This is where you use Redis streams as a data structure because it's persisted and you have the concept of consumer that can register to a specific set of messages. So you see, you have multiple possibilities. You can even using list for that, but I will stay on publish subscribe on streams, but they are between applications, Redis client application, right? It's not used for replication between Redis and so on. This part is for you building your application.
Sure. So you can have like a many-to-many system or many clients publishing to a key space and then many clients consuming events from that. Yeah. Okay. That's nice. Redis has a rich ecosystem. What are some other interesting modules or extensions that you want to mention to our users?
So the modules that I talk are really part of the ecosystem as you want to use new commands on new data structure. But you also have, as you mentioned, a big ecosystem of things like, for example, integrating with tools for monitoring, connector for Grafana. So you can have a Grafana data source you can use Grafana in two ways: to monitor your Redis, but also to inspect the data. You can query, you can do graph, and you can inspect. So ecosystem about monitoring in Redis, it's huge. So you can integrate Redis to your monitoring system into Grafana, into Datadog. And I will say also it's a big ecosystem of having Redis as a managed services everywhere. So Redis Labs is one of them, providing Redis with all the modules online. But it's very important to have something on the cloud today. More and more applications are building this. So the managed services as a database, it's key. And I will say that the big ecosystem is the fact that almost every language has a client. You can use Redis with almost any language you want. So it's plugged in many, many tools.
So to wrap things up, obviously Redis still has that simplicity grounded in its evolution so far. Where do you think Redis is going in the next couple of years? What can we expect?
So the idea is because of the need of fast and reliable real-time applications, very fast application, Redis is used more and more as a database, as a main database for your application. So this is where it's going to. And for this, you need multi-model or multi-programming model with the modules. And a good example is we launched as a community in May last year, Redis AI, and it's going May this year, Redis AI. And this is really where it's coming from. It's really about adding more commands to give you more features to build richer application where only Redis is needed. Not seen only as a cache, but working as a database more and more.
Okay, that sounds really exciting. With that, I'd like to wrap up. Tug, thank you so much for coming on this show.
You're welcome.
This is Akshay Manchale for Software Engineering Radio. Thank you for listening.
Become an autonomous digital enterprise and your business can achieve A-game status. Intelligent predictive systems, effortless automation, and technology and people working in harmony. This is the Autonomous Digital Enterprise. Visit bmc.com/agame for more information. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.